Hey you, welcome back to your channel on JEE Physics Maniac. So we are starting for a long time. There is a brief pause in between. Got stuck into some work. So we are going to discuss this JEE Advanced paper, but on a different note. We are not going to discuss paper wise, rather question wise. So I will try to take you through a guided tour where we can have a complete understanding of each and every single concept that is being employed in the question, different angles how the question can be tackled, and I will try to put 3-4 different methods. Not necessarily we can apply 4 methods, 3 methods in all the questions, but wherever it is possible I will try to bring it. So my suggestion will be whenever you are observing these videos, make a brief note of all the different methods being shown per question, and also try to think out what kind of modifications it can be done to those questions. So it will complete your preparation for the journey of JEE Advanced 2026. Now coming to the questions, so it's a question related to the spring where we can apply energy method, torque method. There is a concept involved for pure rolling, we can apply that, and force method also. So we will take all the things into consideration. I have already done quite a few questions on spring block system connected to a rigid body. So it's there on the channel. You can go through those questions. Now let's focus on this question first. So you can pause the screen and can go through the language of the question. So what are the key words in the question? I will highlight that. So first this one, the other end of the spring attached periphery of both the ring and the disc are in the same vertical plane. This is one key statement. Then this can only roll along inside periphery of the ring without slipping, so that it will execute pure rolling. Important statement. The spring can only be stretched or compressed along the periphery of the ring. Keyword or key sentence, it is following Hooke's law, so it is maintaining perfect elasticity. In equilibrium, the disc is at the bottom of the ring, so mean position of the spring is already defined, correct? And we have to check what kind of angular frequency you are going to have in case of small oscillation. So the first thing, we will attack this question with the energy method. So we know that for a particle executing SHM, kinetic energy plus potential energy of the system is equal to constant. If we make the derivative of this term, ddt of k plus u, it will become 0, which will lead to an equation of either linear SHM or angular SHM based on the situation. Now for this question, we will do first few elemental trigonometry. You first put focus on this diagram, on this triangle specifically, on this triangle, on this situation, you put a focus on this. So here, if you think about the disc, smaller disc I am talking about. So for the smaller disc, you check, this is the smaller disc I am referring to. Total, this radius is capital R, smaller disc is having radius small r. So from here, center of the ring to the center of the disc, the distance is r minus r. So if I take this triangle, you can check this triangle. So x distance, this one, this x distance from this right angle triangle is going to come r minus r sine theta. This is the y. Y is the distance elevated by the smaller disk from its mean position. So this was the mean position of the smaller disk. So y becomes this distance, this one. This is how much? This is L cos theta. Total is L, so elevation is L into 1 minus cos theta, r minus r into 1 minus cos theta. 1 minus cos theta I am plotting 2 sine square theta by 2. Since we are doing the cases for small oscillations, so for small theta, sine theta will be considered as theta. So here x equal to r minus r into theta, y is equal to 2 into r minus r sine square theta by 2 means theta by 2 whole square. So the result come y equal to r minus r theta square by 2. See, without doing all this kind of detailed calculation, I have shown you the detailed calculation. Now this can be done very shortly also, because if you take a small angular displacement theta, then we can have this triangle. Focus on this diagram. I am talking about this diagram. So here you check that this angle is theta. Since this is radius r, this is also radius r. So this angle is alpha, this angle is also alpha. Sorry, this I am going to take as r minus r. So this is also r minus r, correct? So this angle is alpha, this angle is alpha. So now if you look at this triangle at the bottom, I am referring to this triangle at the bottom. This triangle at the bottom. So look at how much angle this 90 minus alpha is going to have. First of all, for this triangle, for this one, for this triangle, summation of the three angles is equal to 180 degrees. So theta plus 2 alpha, we got how much? Theta plus 2 alpha is equal to 180 degree. So This angle is 90 minus alpha because this entire angle is 90 degree. How? Because you can check, this is the radius, and this will be the tangent drawn at that point. So radius and tangent becomes 90. Total angle is 90 degree, out of which this is alpha. So this angle going to be 90 minus alpha. How much you are going to have? 90 minus. If I substitute alpha from here, that's going to be 180 degree minus theta divided by 2. So it is going to be 90 degree minus 90 degree plus theta by 2. So the angle is going to become theta by 2. So the moment you have this angle theta by 2, now the things becomes very easy after this, because then you have a right angle triangle like this. Please focus here. We're talking about this one. This is how much? Theta by 2. Correct? So if this angle is theta by 2, correspondingly we can calculate what is the corresponding value of y, because this one is how much? This one will become r minus r into theta. This is y. So y will become how much? R minus r into theta by 2. So that becomes r minus r into theta square by 2. So there are two different perspectives of calculating the same angle. Now coming back to the question. So when we got x and y, so what is the potential energy of the system? Potential energy of the system, there are two parts. One, potential energy of the spring and potential energy due to gravitation. Spring, half kx square plus mg into y, because the height moved, we are taking this line as a reference line. So if this is the reference line, the bottommost point, so y. So half k, how much is x we got? X value will substitute from here. We are substituting x value from here, r minus r into theta. Y value is how much? R minus r theta square by 2, substitution. So I have taken half theta square common, k into r minus r, mg into r minus r. Kinetic energy is equal to how much? Half I into omega square. Now be very careful over here. Half I is equal to how much? I am calculating about the point of contact. Over the point of contact, IP will become 3 by 2 mr square. Now please focus on this term omega square here. You might be misleading over here. This omega is not the angular velocity about the center of the ring. This is its own angular velocity about this point. This is omega. Now here you have to remember, omega is not equal to theta dot. Omega is not equal to theta dot. So about this point, if the angular velocity I take capital omega is not equal to this omega. Is there a relationship between them? Yes, obviously we can calculate. How we are going to do? Very simple observation you check. If I want to calculate, if I want to correlate between this omega and this theta dot, very simple equation. Since the disk is in pure rolling, so the point of contact must be at rest. Come to this diagram now. Point of contact must be at rest. This is the center of mass velocity. What is the center of mass velocity? Center of mass velocity is simply equal to L into theta dot. How much is L? L is equal to r minus r, we got earlier. This is the velocity due to rotation. How much is omega into small r? Point of contact at rest, so VV must be equal to 0. So V center of mass is equal to omega r. Omega equal to, we got r minus r, capital R minus small r divided by small r into theta dot. We are going to substitute this. So kinetic energy is equal to how much you got? Half 3 by 2 m into capital R minus small r square into theta dot square. Now, what is the observation? Observation is that this plus this kinetic energy plus potential energy. We got these equations. So the moment we got these equations, we can make derivative of these equations. So let us check very quickly. If I make d dt of k plus u is equal to 0. If I make d dt of k plus u is equal to 0, I'm going to write in short. So you can check, half is there into 3 by 2 m r minus r whole square into, it will become how much? It will become 2 into theta dot into alpha. Theta double dot is alpha, or you can keep theta double dot also to avoid any confusion. Plus, if I take this term over here, then k into r minus r, I'll keep them in bracket, plus of mg r minus r whole square. This is constant term. Derivative of this term will become half into 2 theta into theta dot, that will become equal to 0. So if I rearrange the equation, how much it is coming? Theta double dot I will keep on the left hand side, that is equal to how much? That is equal to minus of 2 by 3 into m into r minus r whole square. In bracket, this is, so this will become 2 by 3 divided by, here you have to be a little bit careful in the calculation. So if you are going to do, this calculation is going to come minus of 2 by 3 into 1 by m of r minus r whole square. Inside the bracket you are going to have mg into r minus r whole square plus k into r minus k into r minus r. Right? Correct? Yeah. So now that is equivalent to what? This is equal to theta. So this is comparable to alpha is equal to minus of omega square into theta. Comparing omega value will come out. So this is a very simple understanding or observation that we can have based on which we can do these questions. Now, the same thing we can also tackle by differentiation method. Without any approximation or without doing any approximation, we can first do the derivative and then we can go for the application. What is that? Check here. L is equal to r minus r, x equal to r minus r into sine theta, y is equal to L into 1 minus cos theta, then y is equal to L is r minus r 1 minus cos theta. We are going through the same derivation. K plus u is constant, ddt of k plus u is equal to 0. U total is equal to how much we got? This one. Now, let us do the derivative. It's a bit time taking, but watch out very patiently. So we can do ddt of this k plus u is equal to 0. I'm doing one by one. So first you check half k r minus r whole square. I'll keep it separate. Then it is coming to sine theta into cos theta into theta dot. Right? Fine. Plus mg r minus r into derivative. Into 1 is constant 0. So minus cos theta will become minus of minus plus. So this will become sine theta into theta dot plus half into 3 by 2 m r square into 2 omega d omega dt. That is equal to how much? 0. So now let us regulate this. And please be very careful. So what are we going to have? 2 cancel. K r minus r whole square sine theta cos theta into theta dot plus mg r minus r sine theta theta dot plus of 3 by 4 m r square. Eventually these two will be cancelled, so let us keep 3 by 2 m r square omega d omega dt. Now the same thing, already we had this understanding. What is that? That omega is not equal to theta dot and theta double dot is also not equal to alpha. Alpha means here I am referring to d omega dt. Same understanding here. We have to be very, very careful. So what is the relation between them? We have already seen the relationship between them. So omega is coming to be, omega is equal to capital R minus small r divided by small r into theta dot. Similarly, d omega dt will also be equal to capital R minus small r by small r into theta double dot. Now I am approximating for small theta. For small theta, sine theta is nearly equal to theta and cos theta is nearly equal to 1. So if I use this now, so what I am going to get, let's check. K r minus r whole square, sine theta means theta, cos theta means 1 theta dot plus mg r minus r, sine theta is theta into theta dot plus of 3 by 2 m into r square. How much is omega? Omega is capital R minus small r by small r into theta dot. D omega dt means how much? It is again capital R minus small r by small r into theta double dot. So now you can check r square r get cancelled. What else is cancelled from both the sides? This is equal to how much? 0. Theta dot is also cancelled. So what we are left with? We are left with 3 by 2 m r minus r whole square theta double dot is equal to minus of k r minus r whole square plus of mg into r minus r, that into theta. So if I put it on the right side, so theta double dot becomes minus of 2 by 3, r square cancelled, in bracket it becomes k by m plus of cancelled, g into r minus r by r minus r whole square, so this has become g by r minus r into theta, which is equal to minus of omega square theta. So that's what the technique that we can adopt, which is called energy method. Now we can add a subtle variation to this energy method. We know, if you remember, for SHM, very simple understanding I am going to take. For a simple harmonic oscillator, you might have remembered kinetic energy is equal to, we have written half m omega square into a square minus x square. Potential energy I have written half m omega square x square. Very interestingly, you must have checked k maximum square is equal to how much? Half m omega square x square, which is equal to u maximum. So we are going to check this idea that k maximum is equal to u maximum, and we will take benefit out of this. So now please look at the equation. Here if I apply this, PE max equal to KE max. PE max is how much? PE max is equal to mg into r minus r to 1 minus cos theta plus half KA square. By the way, how much is AA is equal to r minus r into theta. Modifying the result, 1 minus cos theta 2 sin square theta by 2, approximating mg into r minus r 2 into theta by 2 whole square, half k square, mg into r minus r 2 into theta square by 4. Detailed calculation is here, theta square half k square. Now I am trying to express this particular term in terms of a. So what I am going to do, a little bit of calculation change. So here I am writing r minus r into theta whole square. I have written 1 r minus r extra, so divided by r minus r. So this term became mg by r minus r into a square plus half k square. What is the kinetic energy maximum? Half into 3 by 2 m into omega a square. Correct? So the moment we got it, we know that if I write this term, it can be written as half mg by r minus r plus k into a square. So this entire term inside the bracket, it is going to be k equivalent. Whereas if you look at this term for kinetic energy is going to be the term which we can replace in terms of m equivalent, and omega is equal to what we know, under root of k by m. If you use the result, please check what you are going to have, 2 by 3 k by m plus g divided by r minus r. I'll suggest that this is the smartest method through which you can tackle this question. Next, let us come to the method 3. So method 3 we are going to solve in terms of torque method. So first we see that the disc, smaller disc, is displaced to this position. There are forces vertically downward, mg, component mg sine theta, and this component is mg cos theta. Now restoring torque we are going to see. So restoring torque is what? The torque will be provided by gravity as well as by the spring. So how much is going to be the torque applied by gravity? This is going to be mg sine theta into r. By the way, please understand, we are going to calculate the torque acting about this point of contact. So if you take this system, please check out here. We are going to talk about this smaller disc. Through this center, in this direction, what force is passing? The force is mg sine theta. In the same direction, the spring force is acting mg kx. We are going to calculate torque about this point P. So I am talking about torque about point P. So perpendicular distance, this distance is going to be small. So here you can see that this torque is equal to mg sine theta, as I told earlier, plus kx into r. That is equal to how much? I into alpha. So what is alpha and alpha 1 over here? About this point, this is alpha, and about this point we are taking it to be alpha 1. So now this is equal to I into alpha. I is equal to how much? 3 by 2 mr square into alpha. I have already explained to you how the torque is acting about the point of contact. So now let us substitute the value of alpha that we already got. Mr square. How much is alpha over here? Alpha is equal to r minus r by small r into alpha 1. This is cancelled. So 3 by 2 m into r minus r into alpha 1. Now I am going to approximate. So I am writing 3 by 2 mr r minus r into alpha 1 is equal to mg sine theta. So it will become mg into theta plus k into x we already got earlier, that is equal to r minus r into theta total into small r gets cancelled. Put it on the other side. Alpha 1 is equal to 2 by 3 m into, again how much we are getting, mg plus k into r minus r divided by r minus r into m total into theta. So cancellation, alpha 1 becomes 2 by 3, m gets cancelled, inside the bracket g by r minus r plus of k by m into theta, that is equal to omega square theta. Correct? So this is the method that we call torque method. Now method 4. Method 4 we are going to apply the method which is involving the cases of pure rolling. Correct? So here in this case of pure rolling, let us understand. First identify the forces. So through this center as usual mg sin theta is acting, vertically downward mg, and this force is equal to mg cos theta. Friction has to be there since it is in pure rolling. So what is the equation we are going to make? Same direction spring force is acting, so mg sin theta plus fsp minus spring force is equal to mass into acceleration of center of mass. As I have already told you, if we think about now the center, if we shift now about the center, so please check over here, please check. So this one, that is mg sin theta passing through the center, so about the center no torque. Spring force passing through the center, about the center no torque. Which one is going to provide the torque about the center? About the center. Previous one I have done about the point of contact. About the center only friction. So F into R is equal to I into alpha, half mr square into alpha. F is equal to how much you got? M into A center of mass by 2. So mg sin theta plus F spring is equal to 3 by 2 mass into acceleration of center of mass. Again, so I can write mg into theta plus spring force is equal to how much? K into x. X is equal to, already we got how much? R minus R into theta, that is equal to 3 by 2 mass into how much is acceleration of center of mass? Acceleration of center of mass is equal to alpha into R. Again I will convert 3 by 2 m alpha. Alpha is equal to how much you got? R minus R divided by R into alpha 1 into small r gets cancelled. We are going to have the same equation, omega equal to under root of 2 by 3 g divided by r minus r plus of k by m. So I hope you have enjoyed the session. We have tried to figure out and tried to show you how many different methods you can apply to solve the same question. If you do in this way, if you try to think in this way, your preparation will be complete. Wish you all the best for JEE 2026. Bye.